So
something, yeah.
All right.
So I see we have one, is it, I'm probably apologize if I'm mispronouncing, but is it Matthew that's logged in?
Yeah, Matthew.
Okay, and are there others? It looks like there was gonna be as many as 8 others of you.
Yeah,
see.
I think everyone's going to start arriving right now.
Okay,
Oh yeah,
And-
here, so there's Soleil and Samuel.
okay.
Brought,
You wanna give me a
Brought
heads
some,
up when you, yeah, do we have seem like oh yeah, 8 participants. So I think we have about everybody. We're gonna go ahead and jump right in, if that's all right.
Perfect.
Okay, so the first question is the overall design of your rocket contains multiple complex electronic systems. How did the team determine that all the electronic systems would successfully function simultaneously and were mutually compatible under actual flight conditions? And particular EMI and EMC system testing is what's of interest, or others, wherever you want to go with that.
So I can answer it. I'm just to introduce myself. So I'm Matthew. I'm the avionics director for Rocket. So basically, the way our system functions is we have multiple boards which speak with each other over a CAN communication. So basically, we test our boards individually to begin with. We test like rigorously, so all the functions, and then once each board goes through our testing, we put the system all together and run the same tests while the whole system is integrated to make sure that everything works the same way as it worked, works the same way together as it did individually. Also, this is a system we've been developing for the past 3 to 4 years. So a lot of the boards have been through flight tests. Notably, a lot of the Bluetooth arming, our acquisition, our communication modules have all been through multiple competitions, as well as like flight tests that we do ourselves. And then we also have, this year we have a new student developed antenna. And actually we sent that antenna out for testing in, there's a company in the US which offered to test our antenna. And so we actually have characteristics of like our student developed antenna, which is really interesting.
You want to give a couple 30 seconds talk about what about the antenna?
Yeah, it's not my project per se. It's one of our students is doing a master's this year. But basically, it's a hexoidal antenna that he created himself, and I'm just trying to pull up. Yeah, so the company in the US is a antenna test lab, and so basically they were able to put our antenna in I guess a chamber where they could characterize the noise output as well as like the signal strength and everything for us. It's actually really interesting, and it's something we haven't done before. So it's really cool to see the whole process of how an antenna works.
One thing just to follow up on your previous answer too, you mentioned that some of these designs are several years old. Did you this year test 100% of the designs, or do you assume that some of the previous testing was sufficient? In particular, the question would be is if you have something new, you have something old that you knew used to work, but now you have something new in close proximity to it, is there a possibility of issues there?
Oh, yeah, for sure. We redo the tests every year. I was just saying like individually we can like rely on those, but we're always adding new stuff, small changes every year. Like this year we have, it's not major changes, but small changes to all the boards just from issues we found in the past. For example, one of ours was one of our communication chips just like within the avionics box was receiving a lot of noise, or was outputting a lot of noise. And so our GPS sometimes had trouble just having a solid signal. And we actually found the cause of that problem was one of our timer chips, I believe, something like that. Or no, it was, sorry, it was a crystal. We had a crystal that was producing a lot of noise, and that board was actually right next to the GPS. So that's something we changed the board as well as we changed the positioning of that board to really eliminate that problem. And we every year we rerun all the tests with all the boards together. So we don't assume that it's just going to work magically, you know. We always like to confirm rather than just hope it does.
Yeah, yeah. Magic is good, but it's hard to count on it.
You
Yeah.
can't always rely on it. Yeah.
Right. So, okay, if everyone else is happy with that, I'm going to go ahead and go on. So next question is, did the team conduct any comparative testing of the custom quadrifer Helix GNSS antenna to quantify the improvement in performance?
I guess I could speak on that. So that's the student developed antenna that we were speaking
Right.
about. So we do have preliminary tests with the company in the US that I was speaking about. However, we haven't done comparative tests yet because we only sent out our antenna, which was our first. It was the first revision of it. However, we're going to create another version, but we haven't sent out both at the same time to get like solid like qualitative tests comparing both.
Okay, you have future plans for that?
Yeah. With that company, we actually have future arrangements to send out more antennas as well as both to like really get comparative tests between the two.
Okay, this wasn't one of our original questions, but just kind of hit me is, given you're not flying this design this year, are you flying that anywhere else, or is this a design that you would think about just coming back with this next year, or would you have improvements for next year?
Does someone else want?
I can talk. We'll be actually participating in Launch Canada. I think it's going to be in around October. So we're actually going to be flying it. And even if Launch Canada might happen or not, we're not too sure. We'll still try and find a possibility to launch it in some other activities in Canada.
Okay, I figured as much. So okay. Next question. You're flying the same motor as you did in 2019, which underperformed. And yet, let's say it underperformed, yet you're using it again this year. So what analysis and investigation have you done to provide confidence that it will work this year, other than I know there was a note there that the vehicle is lighter, but the question is, why do you feel that you should have confidence that it would work when it didn't perform as you expected? And so how did you, and also your simulations in 2019, did you compare those simulations of the expected results to your actual flight results and try to figure out why it was off nominal?
I think you can go, Julie, if you want.
Yeah, I think we work a little bit more on the aerodynamic of the rocket also. It's lighter than last year, and it's also more aerodynamic. The fins will be more aerodynamic, and so we hope we will gain a little bit of altitude with that. So that's what I can say about that.
If I can add anything, first of all, my name is Joey. I'm an aerodynamic and propulsion member. So I worked, actually, I lead a research project with one of our member, Benoit. And this year, yeah, we use the same motor as the last year. But the main difference here is that we lead some research project on the rocket. For my part, I work on the bulkheads. The bulkheads are a significant weight impact on the dry mass of the rocket. So actually, we work on that for those to be lighter, and we optimize the fins, as Joëlie said. And yeah, that's pretty much it. We work hard on optimize the main rocket for it to reach the 30,000 feet. Yeah.
So your 2019 simulations, I'm assuming, predicted that you were going to meet altitude, and yet you didn't. Is that accurate?
Yeah, exactly. We reached 25,500 feet in 2019, but right now we are on the way to reach about 29,000 feet predicted, but we need a lot of work.
Yeah, and I also think, by the way, my name is Joëlie, and I'm part of also the propulsion department and the aerodynamic department. I forgot later earlier, but yeah, the simulation last time were very similar of the simulation we have this year, but I mean we didn't pay attention to the aerostructure, the aerodynamic of the rocket. So this year we hope to have a flight very much close to our simulation.
Yeah. Also, just add, this year we're a lot more conservative with our simulation estimations. I think last year was we weren't as efficient as we should have been with our estimates. So this year we were a lot more conservative, especially like kind of what Joëlie said with the aerodynamic loss of our rocket.
So if you went back now and put in something into your simulation that you think it's more accurate of what you actually flew, would you get very similar results to what you actually got when you flew?
We haven't done that just because we didn't go back to do that, but I assume we would be a lot closer. Just seeing as how this year we're already at a lower level than what we were last year with a lighter weight, I would assume that it would scale down and we would end up somewhere realistic to what we performed last year or 2019.
Yeah, it's a good way to validate your simulation. Is one thing I'm trying to
for sure.
real data. So okay, I probably beat that one to death. Let me go on to the next one. Let's see. If we told you your mission flew but it failed, what would you expect to be most likely the cause? And based on what have you done to address your most likely failure?
The most drastic failure on the aerodynamic side, I don't know, maybe a loss of pressure because we have a hermetical part for the payload to be deployed, and yeah, maybe it could be that, and with the differential of pressure, yeah, maybe it could be a critical issue that we could have.
And is there anything you've done based on those concerns?
Yeah, in 2017, I guess, or 2018, I don't remember. We have something like that happen. The rocket just explode in the sky and fall in two parts. So yeah.
Although this year the payload is something that we've spent like integrating the payload properly is something we've spent a lot of time on. Just since we're using a lot of similar components to last year, we've been able to focus more on really streamlining the enclosure for the payload and making sure that it seals properly. So that's something we've spent a lot of time and looking into different ways that we can integrate it.
Okay, very good. All right, one last one, which is more specific to this year than most years. So COVID presented many unique challenges to this competition. Can you describe any unexpected opportunities and any unexpected challenges that COVID presented to your team's engineering process and preparation?
I can start. Yeah. Just for avionics side of things, it's been very hard to get. It's getting better now, but beginning of COVID, it was really difficult to get components, and just manufacturing printed circuit boards was also really difficult when there was a lot of restrictions in place. So it was very difficult conception wise to create a board but not be able to send it out and get the components to test that board. The way we dealt with that for us was we made sure that all our conception projects were done. So we had a lot of separate boards that we wanted to get done this year. So basically we, rather than doing our normal procedure, which is like creating the board, sending it out, manufacturing it, putting the components on, and then testing it, we basically conceptualized all our boards. And then as soon as we were able to send those out for manufacturing, we sent them all out. And then we've been doing testing pretty regularly with those boards ever since we've been able to.
Yeah. And for the aerodynamic side, it's very a lot of member left, and it's difficult to recruiting. So we had a hard time to find people to work actually on the rocket. So it was really, really challenging. Now it's getting better, as Mathieu said, but we had a pretty rough time.
Also to add, we didn't have access to our any of our materials at school, because basically the whole school had shut down, so we weren't able to access all our on-site equipment. And also because the school wasn't technically open, we weren't allowed to buy components to test at home either. So we were basically locked out of working on anything for a good chunk of time at the beginning of the year. So that made it difficult to hold members as well as get new members, kind of how Joey was saying.
Okay. Anyone else want to add anything?
I'm Salim. I'm from the avionics team, and also a big part is not a lot of members who are older, like members, didn't want to participate in Ezra as much because we weren't launching a rocket. So we're mostly all new, working on the document and everything. Well, pretty much all new members here. So.
Well, we get fast on the learning curve that way.
Yeah,
Yeah, exactly.
we had to learn everything in one shot. It was pretty interesting. It was fun.
All right. Well, I appreciate it. I think we're about out of time. Does anybody want to jump in, Steve or Chris? Any last thoughts or questions? Or
no, all 5 questions. Thanks, team. That was a good presentation. I enjoyed reading your technical report and watching your videos. Thank you very much.
Yep.
Thank you very
much.
Take care.
I really appreciate the questions. Thank you, everyone.
okay.
Yeah.
Thanks.
Have a good
Thank
rest of the day.
We'll look for you next year. All you
Yes.
youngsters.
Of course, thank you.
There we
Definitely.
go.
Like to see us next year.
Thank you. Have a
Thank you
great
very
day.
much. Have a good
Bye.
day.